So here we're going to determine whether each infinite geometric series converges or diverges. And then if it does converge, we're going to determine its sum. So again, it comes down to that R value. For A, what's happening when you go 32 to 8 to 2 to 5? You're dividing by 4, right? Dividing by 4 is the same as multiplying by 1/4. So that value is less than 1, so we'd say this one converges. So if we want to find that sum to infinity, term 1 over 1 minus r, term 1 is 32, 1 minus 1/4. Now when you have a whole number divided by a fraction, your whole number can be written as a fraction. So same thing, I have 32 over 1 divided by 3/4 is the same as multiplying by the reciprocal. And we get 128 over 3. I believe your answer at the bottom there actually gives a decimal, right? So if you type this into your calculator, you get 42.6 repeated. That's fine if you wanted a number. If you wanted to leave it as a fraction, you could. Yes, Andrew?
Mine says 42 2/3.
Okay, so sometimes with your calculator, it can print in math print or it can print in decimals. If you want it to be back in decimals, I'll show you after how to put that in. So there's example A. For example B, what's happening here? We're dividing by 10. So your R value would be 1/10. Also notice it's changing, right? Positive, negative, positive, negative, positive, negative. So then your R value is negative. Oh yeah, I'm going to change this to B. I'm going to keep the formula there. Oh, we're working in green, so there we go. Oops. Take that too, right? Make that green. Excellent. Okay, so now we got our formula here. We're going to do the same thing. Now term 1 for part B is 100. 1 minus a negative 1/10, which is the same as 1 plus 1/10. We'd have 10 over 10 plus 1/10 gives me 11 over 10. Again, it's a fraction divided by a fraction. On the top, I have a fraction 100 over 1. Multiply by the reciprocal, which is 10 over 11. And I get 1,000 over 11, which at the bottom they actually change it to a decimal. I would leave my answer as a fraction like that. You wouldn't have to change it to a decimal unless it says what they would like it to be, to 2 decimal places or something like that. So this one also converges. And the basic thing with infinite sums, sometimes they'll give you a question where it tells you the infinite sum. Can you find term 1? Or it tells you term 1 and the infinite sum, and you have to find R. So it's just working with the formula like we did before, and you can figure those things out. The questions we do for this one are 5, 6, 7, and 10. And I'm going to give you time to work on those right now. If you go to example 3, oops, there's example 3. We are not going to be quizzed on this. This is not going to be on the final exam. It's there for you to read if you would like. If you would like to know how you can use this strategy of an infinite decimal to change it to a fraction, you can read that example, but you can write skip because we're not going to be quizzed or tested on example 3. That's just there for your own interest. And we are now done the first chapter.